A Venn diagram is used to organise information into categories. We use circles to represent each category, and we use a rectangle to represent all the information that's included in our diagram. We use this Greek letter epsilon there, this sort of squiggly E shape, to represent every piece of information in the diagram, and then we use capital letters to represent each circle or each category. So in this example I've just drawn out here, the epsilon represents all positive integers that are less than 10, the A represents all the odd numbers, and the B represents all of the square numbers. So we can see that I've put the number 1 in circle A because it is an odd number, so I've put it inside circle A, but I've also put it inside circle B because it is also a square number. The number 2, I've put that over here because it's not an odd number, so it doesn't go into circle A, and it is not a square number, so it doesn't go into circle B. So I can put it anywhere on the outside, inside this outside of the circles, but inside the rectangle, because obviously it is still a positive integer less than 10. So it can go anywhere inside the rectangle, but not in the circles. Number 3 is an odd number, so I do have to put it inside circle A, but it is not a square number, so it can't go in circle B. So that's why it has to go in here and not in here or here. Number 4, that is, it is a square number, so it will go into circle B, but 4 is not an odd number, so it won't go into circle A, so it has to go there. And you can see I've already filled in the rest of the numbers into that diagram there. That's pretty basic. That's not the point of this video. That's just a quick recap of what Venn diagrams are. The rest of this the rest of this video, not Venn diagram, the rest of this video is about notation and understanding what that means in terms of a Venn diagram. So we're going to start off by just shading different parts of this Venn diagram based on the letters on the outside. So very simply, if I want to shade all of the region that represents circle A or category A, it's that. That's the circle that represents A. Very simple so far. B, that's that. Now the next one, that little dash there, A dash, that means that it is not in A. That's what the dash means, it means not. So the region on this Venn diagram is that represents not A is all of this. This is the bit of the Venn diagram that is not A. So everything that's not the A circle. B dash means not B, so that's anything outside of the B circle. So that's all of this. So hopefully that's pretty simple so far. Next, we're going to start to look at combinations of A and B. So let's talk about what these two symbols down here mean, first of all. This symbol here means and, or the intersection. It means it has to be in both of the categories. Whereas this symbol over here means or the union, which means it can be in either of them. So if I wanted to shade the region that was A and B, well, that's this part here. This is the part of the Venn diagram that is in circle A and circle B. Whereas if I wanted to highlight or shade in this region, that can be in circle A, which is all of this, or it could be in circle B, which is all of this. So it could be in either of them. It doesn't have to be both, could be either. Next, we are now combining both of those things together. So I want the region that is not in A, but it's also in B. So not in A, but in B. So first of all, if I were to do this, that would be all of B. So that would satisfy this part, that would be good. But it also, because of the union here, the intersection here, that means it also has to be not in A, so it can't be that bit there. So now we've got this part here, just this part here, that is the bit that is not in A, but it's also in B. And then we will do this one. This is the region that's not in A, or it could be in B. So it could be in B, or it could be in not A. So it could be anything on the outside here, because this is not in A. So notice with this one, I have actually ended up shading this inside region here, which is in A. So that doesn't necessarily satisfy this one, but that's okay, because with the or in the middle, it doesn't have to be in not A and B, it just has to be in one of them. This bit here is in B, so that's good. It doesn't have to be in this as well, because it's an or. And final example for this video, we're going to extend this into 3 categories. So we've got A, B and C now. Region A, that's just circle A, so that's just all of that. So nothing complicated with that, hopefully. Region not B, so that's anything that is not in the B circle. So anything on the outside here will be in not B. Now we've got A and B. So the bit that is in circle A, so in circle A and in circle B, so that's this bit in the middle here. It does include a little bit of circle C there as well, but that's okay, because that part there is still in A and in B. Now we've got the A or C. So it could be an A, so it could be in this one, or it could be in C as well, so it could be in this one as well. So that is the union of A and C. Next, A and B and C. So it has to be in A, B and C. So that's this part down in the middle there. That bit there is in circle A, it's in circle B, and it's in circle C. And last example for the video, it's in not A, so it can't be in circle A, but it also has to be in circle B and C. So, well, this is the bit that's B and C. So this is B and C, because it's in circle B there, and it's in circle C there, but it can't be in A. So I have to rub that bit out there, because that bit's in A. So this is now the region that is not in A, and it's in B, and it's in C.